Hello everyone, my name is Shane Hutto. I own Horticultural Solutions. We're based out of Denver. We operate on a global basis. We are truly a technology company for the greenhouse industry. My big discussion today is farmer-grade greenhouse production. We are really driving to push the technology in this industry and take the things that we've seen innovated around the world and even push it farther. That's something that I've devoted my life to and I'm very passionate about, is just making all of our industry more successful and growing, giving them the tools that they need to accelerate growth. You know, over the past decade or so, we've seen tomato production go from 60, 70 kilograms a square meter to now we have guys pushing 120. My personal background is started with not only a horticultural education, but also consulting for many companies in this room in the tomato side, cucumbers, and then evolving into the medicinal plant side where I find my true passion. We started working on the farmer grade production several years ago and found some of the pitfalls and the things that really needed to change to be able to evolve to what we call a GMP certified facility and change the technology, and we've developed our own technology around that. So today my main discussion is farmer grade production in greenhouses. Previously we've really seen that farmer grade production has not existed. It's been research for farmer grade. That's been, large companies, Monsanto, Bayer, the people that have innovated and really spent all kinds of money on the research, but very few people have done the actual production on a farmer grade level. This goes beyond food safety to a level where we need to be contaminant free and chemical free. And so that is our goal as a company, to really drive this industry on a global level. We're not talking about the United States. We've seen, Canada do some amazing things from the aspect of medicinal production. Now we're seeing, many more states around the US, but we're also busy in Europe, South America. It's become a global movement to produce quality medicinal plants in a way that is safe medicine. That's what we're really after here, is safe medicine that a patient can consume responsibly and with a peace of mind, knowing that they're not going to consume something that's going to further worsen their ailments. To get right into it, my main things today are address why we want the farmer grade production, why we're driving towards that, and then how are we accomplishing that. To start about the why, in the tomato and the vegetable world, we've seen push towards semi-closed greenhouses, which for those of you that don't know, what that means is there's some air intake from the outside being brought through the greenhouse and treated, recirculated, and then when it makes sense, they bring in outside air because they're trying to save energy. Energy is also a big aspect of this because that's your operational cost. So with the farmer grade situation, not only do we have to have the right technology, we have to take in consideration the operating costs and the resources that drive behind that. So we are really pushing beyond the semi-closed system and going towards a fully sealed system, which we've seen in the controlled environment ag rooms and the warehouses, the indoor facilities that have popped up around the industry. But we need to take that a step further and do it in the greenhouse sector, because we still need the natural light. That's where, as a greenhouse, our major energy savings comes from. Not only are we saving energy on lights, we're getting more light because artificial lighting will never compete with the sun. To my point just a second ago, the medicinal market is a global market, and we're not talking about one crop. There's, several crops around the world that throughout history we know to have medicinal properties and to really help people on a day-to-day level have a better quality of life. As the US legislation changes and the Canadian market evolves, and we're starting to see other countries around the world evolve from a medicinal aspect, it becomes a global market. And what that means is at some point we're going to evolve to import and export, and if the governments regulate it properly, we'll even see the tariffs around that. So we are evolving to that point. We are competing against the entire world, not just competing within each state. And to compete around the world, and it's already established for import and export in particularly the EU, you have to have CGMP certified, good manufacturing practices that are certifying your SOPs, your facility designs, the technology that you're using to accomplish this. And the biggest thing about that is the API, the active pharmaceutical ingredients. And to qualify for an import to most of these countries, you have to have a very tight, consistent API. And that is very difficult to do if your environmental parameters and your growing parameters are not very tightly controlled to a tight specification. That's really accomplished through automation and then proper environmental control. As we know, greenhouses have heat loads from solarization and heat loss during winter from ambient temperature. So we have to have the technology and the infrastructure to maintain that very tightly, regardless of what's happening outside the greenhouse. Contaminant free. That is the number one key to all of this, is if you're producing medicine, you can't have contaminants. Now, certainly there's different extraction procedures to remove some of these contaminants, but we shouldn't have to go through that. We should be able to produce products and plants on a level that are contaminant free. That also means pesticide free, heavy metal free, microbial free. And microbial, we're really looking at molds, yeast, fungal spores, anything that you yourself wouldn't want to consume as a patient or individual. This really goes beyond food safety, and that's why we call it pharma grade. And pharma grade is not something that you can really truly certify at the moment. That's still beyond our scope. But we are working with ASTM standards and able to produce what we internally call pharma grade, because the food safety aspect doesn't quite get there. When you go to combust some of these medicinal herbs, anything that's residual in there, you're combusting, vaporizing, degrading the molecular structure to be something that could very well be toxic. And that's what we're trying to go beyond, is the actual contaminants. We also want to be chemical free as far as a treatment aspect. That's not to say we don't use synthetic fertilizer, because the plant's still metabolizing that. But it's really the pesticide and the foliar treatments that we're trying to avoid with this pharma grade production. The how. There's several pieces of technology that we've seen around the world, and this is something we very commonly see now, is these tubes that started use in tomatoes and cucumbers, mostly in the semi-closed greenhouses. Well, we see that as a very good application because you're blowing air from underneath the crop. The air travels vertically, and the air is not only treated, but because you're blowing the air vertically, it prevents dust and debris and contaminants from landing on the plants. That's one of your first steps. Also, you're removing that moist, humid air from inside the canopy underneath where it really stagnates. And because you're removing that, you're preventing the disease outbreaks to begin with. Our technology, which I can show you in the booth, we have it on display, takes this even steps further. So this right here is really just a picture, a graphic, if you will, of how we're applying the tubes between the rows of plants and blowing the air vertically. The air needs to sit below that canopy and inside the rows, and we do them in a double row stance so that you can have an aisle between each double row, but you're still applying that air in a way that removes that moist, stagnant air that would otherwise be causing an outbreak of mildew, molds, yeast, things like that. And you can see from the graphic behind that where, because we're using this technology in a way, we have to have air handlers, and that requires us to have an air management corridor that's separate and partitioned off so that we can control a circular pattern of airflow. And What that allows us to do is actually treat each piece of air in a facility. Our technology treats each piece of air every 6 minutes. And so that air management corridor, while you're losing some square footage, is incredibly valuable to the quality of the crops you're producing. And so this is, on the left, is actually a picture of our air handler, purpose-built greenhouse air handler. It's the first of its kind on this level. There is one other firm that makes a air handler that has a bottom feed underneath the plants, but we've taken that a step further. We've added a UV filtration and a debris filtration. So that way we're actually taking 2 more steps of contamination prevention. You can see the way that we build this partition. We pull air, the moist, humid air, from the top of the greenhouse portion only. And we can actually control that airflow with the louver, and it pulls down into the air handlers. And so it's a top-down feed, and it goes through the debris filter first, then it gets past the UV sterilizer and actually kills any airborne pathogens that might be present, mold, mildew, spores, anything else that's airborne. And then it goes out and pushes underneath the plants. We also have our air handler is made in a way that is very easy to wipe down, very easy to sterilize, and it's very low maintenance actually. Because it's a hydronic system, it has hot and cold piping. It allows us to control temperature and humidity independently, as well as the airspeed independently. So that's 3 different parameters of control, and that can either be with a simple control, just running the valves and the airspeed, or it can be done with any PLC system that's currently available in the greenhouse market. So the important concepts here, number 1, we're having positive pressure. Anytime you open a door, the air is going to blow out at you. This is going to prevent bugs and other contaminants from crossing into your cultivation space. Also, the recirculating airflow pattern. We talked about resources. Because we're recirculating this air inside the growing areas continuously, every piece of air gets sterilized and treated for temperature and humidity. And by recirculating versus bringing in ambient air like you'd see in a semi-closed system, it actually lowers our cost of resources because our boilers aren't running at full strength and our chillers aren't running at full strength all the time. You're retreating that just like you would in this building. Although it's a large building, they're recirculating that air and treating it continuously. And that lowers the cost of resources versus trying to treat the outside Columbus air that's hot and humid all the time right now. Same concept. The other really big piece is your phytosanitation practices. Not only are we treating the air, your SOPs, your operating procedures have to be in line to keep the environment clean. Because if you leave leaf material or dust and debris on the ground, well, that's a chance for contaminants to build up and spread throughout the house. So while you have the technology, you also have to employ the practices. And that's really the driving point behind our whole package as a company, as a technology company, is not only do we want you to have the right technology, we want you to have the right practices, and we're going to help you monitor and adjust those procedures as you need them. You can see here there's a bit of a close-up as to how we apply the air to the plants. We definitely strive to have air between every row of plants to where you're not getting that buildup of stagnant, moist air that could cause problems. The other part that leads to is your chemical cost goes down dramatically. You're not spending money on your fungicides and even potentially your pesticides. And to the pesticide point, when you seal a greenhouse right now, the data shows that you see an automatic 80% reduction in pest presence because you have a sealed environment. There's no way for the bugs to come in and out except on your employees. And if you have your proper procedures where your employees are suiting up, at least in some sort of coverall or going through an air shower, stepping on your bleach mat, sterilizing your hands, there's a very low likelihood that you're going to bring in pest and disease on your employees. How do we monitor this? We have sensors everywhere, and we split these into zones because, as you know, your outside edges, your walls along your side walls, your gable ends, everything's going to have a microclimate. And to try and balance that, we're splitting those zones accordingly and putting sensors in every zone. And we have lots of different types of sensors, as many of you know, CO2, light, temperature, but we also have VPD sensors, infrared cameras that can monitor leaf temperature compared to air temperature and make computer adjustments on that. We also very much so recommend the root zone moisture content meters so that you can continually track the moisture within your root zone and apply that to your irrigation strategies. You don't want your roots staying too wet. You certainly don't want them too dry. So we balance that out, and we actually have written strategies for each phase of crop development to where you can track that moisture level, track the amount of dryback every day, and make those adjustments because every day is different. Some days are sunny, some days are cloudy, sometimes it's cold, sometimes it's hot. And those things have to be adjusted by the grower. Now, if you have the right computer system, the computer has logic, it can make some adjustments for you, but if your grower is really doing his job, then he should be making those adjustments and certainly watching those sensors every day for every zone. That is his job, or her job. So the other big design pieces that we employ are really water conservation. Our technology, our air handlers are designed for 1,000 feet per unit, and we can make larger ones and smaller ones. But one of the biggest keys is that all of that dehumidification we're pulling out of that sealed environment is actually going back into our irrigation system. And that allows us to really be what I call water neutral. We pull enough off of those condensation coils that we get about 50 to 60% of our daily water needs. Well, we're also collecting all the drain from the runoff of the plants and measuring that, and that goes back into our irrigation, and we can reincorporate that. So that really takes you up to about 70, 80% of your daily water use. So what you're pulling out of the Earth's natural resources, whether it's your city or well or whatever, you almost need no water off the grid. And that's a really key point as water becomes a scarce natural resource in our world today. Electrical and natural gas are definitely, some of our biggest consumption areas. Because we are a sealed system and we're retreating that same air all the time, we actually have a lower pull than what you would see in a semi-closed greenhouse where they're pulling in that occasional air that they have to spend more energy to treat than if you just retreated the same air. Odor control. A lot of us are very aware that the medicinal plant market has odor issues. Most of the time it's your neighbors complaining or a city municipality complaining. While when you seal this greenhouse or an indoor controlled environment room for that matter, your odor stays contained. And you still have that small amount of positive pressure, but if you direct that positive pressure in a way that runs through your ancillary offices or your processing space, your pack house, that can easily be treated in one room versus trying to treat the odor for the entire facility. And that's really a big driver for a lot of our customers, is the fact that they don't have to worry about being a nuisance to their neighbors with this odor. Optimized climate. This is probably the most important piece of what we do, is optimizing your climate in a way that keeps a very tight spec all day long, all night long, and doesn't have a huge change in VPD, when you vapor pressure deficit. Whenever you make large adjustments or you have large swings in temperature or humidity, well, that's where the mold and mildew spores are going to germinate and sporulate. They're going to spread. And if you can keep that very tightly consistent, we look for a 5% or less variance throughout day and night all year round. And if we can't do that, we're not doing our jobs, or we're not employing the right technology. So keeping that climate optimized to the perfect parameters all year round, day and night, with very little difference, is going to be the major key to preventing disease outbreaks in what we do and keeping things chemical free throughout the facility. When you look at the cost of what we're doing versus the cost that a lot of these guys spend on chemicals, it almost pays for itself. That's a big driving factor in your capital expenditures installing a facility like this, is lowering your chemical cost. And then we go into, well, I'll skip a couple, but we go into lowering the labor cost as well. Because so much of this is automated with a computer, you take the human error out of it, and by not having the chemical costs, now you don't have to have the labor to spray it all. Where we spend most of our labor is actually in the crop work, maintaining, pruning, and doing the things that most of the crop labor enjoys versus the grunt work that people hate of spraying and having to clean dirt off the floors and make adjustments to the computer every 20 minutes. Greenhouse is definitely the key for me. I'm not a big fan of the controlled environment rooms simply because you don't get the light. The amount of money you spend on light for, let's say, a 30,000 square foot cultivation area, you can spend about $500,000 more a year if you're indoors using artificial light and get less output than if you just have a greenhouse using supplemental light a couple hours a day. And that's a big number if you're the owner of a company or one of the executives getting a bonus. That $500K can go in your pocket instead of spending it on lights like these. Well, not like these, but HID lights. We also talked about the fertilizer and how we're collecting all the runoff from those plants. Fertilizer cost is, along with your pesticide cost, is a huge expense. And particularly some people are using very expensive fertilizers. Being able to collect that and reincorporate that back into your system is always something that you want to think about. I mean, you could save hundreds of thousands of dollars just by collecting the runoff from your plants instead of running it down the drain. Also, when you go to apply for your permits, your municipality, instead of putting it down their sewer, which most of them do not like, you're collecting that, reusing it. Even if you're not running it back out to your plants, you can use it on your landscaping. There's no sense in wasting all the money you put under that fertilizer and just putting it down the drain. Big take home for me in this speech is that efficiency is everything. We are here to create efficiencies and technologies that are going to help our customers be successful. We look for long-term relationships in what we do, and really the efficiency is everything. We have a tagline that we love. It's automate or stagnate. And if you're not driving forward and progressing what you're doing and innovating, then you are stagnant. You are going to fall behind the curve. You're going to fall behind your competitors. And we all want to be the best at what we do. That's why we're here. Every person in this room is here to learn, here to progress. You have to push forward. And realistically, in today's technological world, especially the greenhouse industry, you must automate things and look for new innovative ideas. Precision in every parameter of what you do. We collect data on everything and every zone. We probably take 1,000 data points every 2 minutes and look at those, and those are separated into categories, and we graph them, and we compare each graph to each other, and those can be done on a daily basis, a weekly basis, a yearly basis, and the data collection is what's going to make you better. But simply collecting the data isn't enough. You have to go back and analyze it and compare it and really run this like an efficient business. Even if you're producing medicinal plants and you're making huge margins, you still should run this like a well-oiled machine. It has to be a good business decision on everything you do, and those decisions have to be made on a daily basis. I can take a few questions.
What's your average cost on setup per square foot for a sealed facility like this?
So a sealed facility like this, for a greenhouse, average cost, we're probably somewhere around $135 a foot for the cultivation areas. If you want, to go up in technology and up in automation, that can go up to about $150 a foot. But we also have facilities that we know not everybody has that kind of investment money. We can go cheaper and make some adjustments to have fewer automation. There's a real trade-off between the amount of technology versus the amount of labor that it requires to run. Those numbers are with install, yes.
Thank you very much. My question is, well, this clearly we're talking about cannabis, but during your presentation, you were mentioning how there are other medicinal plants. Can you share with me what other medicinal plants would justify such an investment on them for pharmaceutical grade?
I
production?
think there's a lot of other medicinal plants around the world. I think North America is very focused on the cannabis plant, but we've seen great results out of the kratom. Even there's facilities in other countries that grow poppies that are very much in line with what we're doing here.
Okay. And when you mentioned you collect around 1,000 data points like every 2 minutes, you obviously need some pretty serious statistical software to run through that. What software do you usually use to collect this data and run it through? How do you work with it? I mean, do you use Infostat? Are you using R?
We've used several different computer companies, PLC systems.
Okay.
We've worked with Priva and Argus over the years. Currently, the one that I find suits my needs the best is Hogendorn.
Which one?
Hogendorn.
Hogendorn.
They're a Dutch company. They have
Okay.
a booth. I don't know what the booth number is, but they're here. And you can also find some of their flyers at our booth. Thanks, guys. Appreciate it.